All right. We're going to spend the rest of our time talking about functional groups and hydrocarbon derivatives. Up to this point, it's been all hydrocarbons, right? Just C's and H's. But that only gets you so far. Pretty much anything that's just a hydrocarbon is something that was distilled from crude oil. Okay? All of the alkanes and alkenes and alkynes pretty much have just come from being distilled from a certain boiling point range out of crude oil, essentially. Hydrocarbon derivatives, though, that's where we get into actually interesting, useful compounds. You notice the structures of those over-the-counter drug molecules that I showed you. Those were not just hydrocarbons. Those had N's and O's in them, and that's usually where the interesting stuff happens. So a hydrocarbon derivative is a hydrocarbon which we're going to represent as R, just as sort of a wild card to indicate any kind of hydrocarbon group. Okay? So it could be a chain or a ring or anything with just C's and H's in it. That's what R is. Okay? And then a functional group is just a characteristic group of atoms, a certain pattern of atoms that makes a class of compound. Okay? So these are the simplest of the functional groups. We're going to go through each of these and learn a little bit about each of them, how we name them. You will come to find that we're going to give each of these a general formula, which has an R group with whatever the functional group is. And remember, we said that R can be any kind of chain or branch or ring or anything like that. But the thing that makes it that type of molecule, for instance, in alcohol, we have an OH group attached to the rest of that R group. So that's what that general formula is. And there's usually a suffix. Okay. Characteristic functional groups have characteristic suffixes. Okay. You'll notice the end of each of those names, right, is sort of different. So the names will end based on what type of functional group it is. The names will start. What do you suppose that? Notice sort of at the start of it, there's a methyl, there's an F, there's a prop, there's an F, there's a meth, there's an F. What does the start of those names in each case refer to? Yeah, it refers to the hydrocarbon group. Okay? It tells you what kind of carbon chain it is or whatever. So just the same way that we've named those so far. We're just adding these suffixes on the end of these names to indicate functional groups. Okay? So let's start with alcohol. ROH, so a hydrocarbon with an OH attached to it is an alcohol. The suffix for alcohols is ol, O-L. Okay? We're going to take the name of a hydrocarbon, essentially just replace the last E out of methane, ethane, propane, butane, whatever. We're going to replace that with ol, okay, to make an alcohol. So this is we're going to make two columns here. Okay? We're going to have IUPAC names and common names. Okay. Because alcohols have a lot of very widely used common names, but thankfully they're pretty similar, and they all follow a really nice pattern. Okay? So if we just take an alkane, if we replace one of its H's with an OH, essentially, we get an alcohol. So we take the E off of the end of the name of an alkane, replace that with ol. So if I have a one-carbon alcohol, okay, CH3OH, it's not CH4OH because that carbon still needs 4 bonds, right? 3 of those will be the H's, but instead of an H over here, that's the OH of the functional group, right? So that's why it's CH3OH now. What would the name of that one-carbon alcohol be, if that's the pattern that we said? Yep. So it would be just methane, right, for the one carbon. If we remove the E and change that to OL, that is what? Methanol. See how that works? CH4 is methane. Everybody get that pattern? The regular alkane is methane. The alcohol is methanol. Right? So that's the IUPAC name. Okay, let's just do all the IUPAC names, and then we can do all the common names at once, because it's a real simple conversion. Okay, so what about this one here with 2 carbons? Ethanol. Ethanol is the alcohol that is in beer and vodka and alcoholic beverages, right? It is the alcohol that is added up to 10%, I think, in fuel in Minnesota. Okay, we have that added as a fuel source. Methanol is wood alcohol. Ethanol is grain alcohol, if you hear them referred to like that. Okay? This is a line structure of ethanol. Be careful with the carbons here, right? There's a CH3 right there. There's a CH2 right there. And then this line here is the carbon-oxygen bond. Okay? Don't try to squeeze in another carbon at the end of that line. This is showing the CO bond itself. Okay? So ethanol is there and there. Okay? What do you think about this one? Prop. Right? Same with this one, right? CH2, CH2, CH3. So, how many carbons does this one have? Yeah, that also has 3 carbons, right? Here's the CH3, but a CH3 on the end. What's this middle carbon? CH. Yeah, 1H, because it has 3 other bonds to it. Okay? So what's that one called? Well, sort of. Because it's still 3 carbons. Yeah, well, hold on with the iso. That's going to be over in this column over here. Okay? When we had things located in a different place, think of this OH now sort of more like a branch. Okay? How would we differentiate this one from that one if it's kind of like a branch that's in different places? Let's number those carbons. Let's call that one 2-propanol. Okay. Let's number the carbon chain from the end that's closer to the functional group. Okay. Sort of like we've been doing all along, right? What would this one be called then? Yeah, should have left myself a little room, but yeah, that is 1-propanol. Okay. The IUPAC name, remember that's sort of the standard rule-based name that uses a number to show the location of a functional group if there are options for where it could be. Okay? We did not need a number in ethanol because 1 ethanol and 2 ethanol, that's actually the same molecule. We would have just numbered from the other end. Okay? But now we have 2 actually different molecules where it's either on an end carbon or on a middle carbon there. Okay? So 1-propanol, 2-propanol. So when we're doing an IUPAC name, and it's complex like this, we have to find the longest carbon chain, number it from carbon to carbon, okay, numbering from the end that's closer to a functional group. Okay. How long is the longest carbon chain in this one? Yeah, it's 3 carbons long, and you can actually choose any carbons you like, okay, because it's very symmetrical. Okay, so you can do whatever you want. I mean, either way, carbon 2 is going to be in the middle there, but you could choose any of the 3 to be carbon 1 or carbon 3, right? So with that, any ideas for naming that one? Well, there's definitely a 2 because we have the OH attached to 2, okay? But there are 3 carbons in the backbone, right? So it's going to be a 2-propanol again. Nope, you only count the carbons that are in the backbone because this one is a branch. And that? So what would we put on the start of the name if that one is a branch? 2-methyl. Okay, so that's 2-methyl 2-propanol. So if you've got branches, if you've got stuff going out all directions, okay, go back to the IUPAC rules that we use where you find the longest chain of carbons. Okay, you name the alcohol based on that backbone. Okay, that's sort of your base name. Okay, and if it's 3 or longer, you need a number to show where the functional group is attached. Okay, so that backbone is just the 2-propanol backbone, much like the one that we had above it there, but now we have an extra branch that's also attached to that central carbon. Okay, so I mean, these end up being really very similar, but just based on the structure, that's not quite as clear. Okay, so back to common names. I'm just going to give you the common name for this first one, and you will immediately see the pattern. Okay, methanol, its common name is methyl alcohol. Oops, AlCO. Okay. Instead of turning methane into methanol, we treat the R group more like a branch when you're naming it common names. So that's like a methyl group attached to the alcohol. Okay. So methyl alcohol. So ethanol would be what? Ethyl alcohol. Okay. 1-propanol would become. Yeah, and we actually have to specify what kind of propyl, right? It could be, I mean, just propyl is not entirely correct. It could be 1-propyl. Or it could be N-propyl. The one with the N might even be used a little more commonly. Okay. Now, Andy, it's your turn. What's this one called? This is isopropyl. Okay. Because if we treated this like a branch, right? If we pretended this part was a branch on part of a larger molecule, that would be an isopropyl group. Okay? So it's just sort of a little different perspective for it. Okay? So that is isopropyl alcohol. It's commonly used as a disinfectant. A lot of you probably have some in your medicine cabinet. Okay? Rubbing alcohol, that's what it's called. Okay? Do not confuse rubbing alcohol from grain alcohol for wood alcohol. There have been several misinformed people that have been unfortunately poisoned by not getting their alcohols straight. This one actually has a name because this kind of group has a name as a branch. It looks like this. That is called a T-butyl. That's a lowercase t. That is a T-butyl group. And it's called T-butyl because it looks like a letter T. So in case you ever encounter a group like that attached to something, to a longer chain, or to benzene, you can have T-butyl benzene, just like you could have isopropyl benzene. Okay? But that would make the common name for this one T-butyl alcohol. Okay. So, if you are ever asked to provide a name for an alcohol, you will always be correct providing an IUPAC name. Okay? That will always be correct. You should know, I'm going to indicate some common names that you need to know. Know this pattern of common names. Okay? Again, it's not individual common names that you need to memorize, but rather what the pattern is between IUPAC and common names for alcohols, because those are very widely used. Okay? Anybody have any questions about those? We had a section on oxidation and reduction in first semester. It involved electrons. Do you remember what we said about oxidation and reduction? What was an oxidation in terms of electrons? Remember that? I gave you a little thing to remember. Yeah. Yeah, you do oil rig, or you could do Leo the lion says grr, right? So what is an oxidation? Yeah, oxidation is a loss of electrons. Reduction is a gain of electrons. Okay? But that's really tough to see when you have an organic molecule, because we usually don't count the electrons drawing organic molecules. We just give everything the right number of bonds. Okay? So instead, we have another very consistent way of tracking oxidation and reduction in an organic reaction, okay? Compound with organic compounds. When something is oxidized, we add more CO bonds. Okay? And that's sort of another way that oxidation kind of makes sense. We add bonds between carbon and oxygen. Reduction, we add more CH bonds. Okay? And with those, and opposite for removing bonds. Okay? So if we remove CH bonds, that's an oxidation. If we remove CO bonds, that's a reduction. Okay? It's sort of the opposite. But adding CO bonds as an oxidation, that's the easiest one to remember, I think. Okay? It's becoming oxidized, so we're making more bonds from C to O. Okay? So alcohols can be oxidized. In doing so, it makes an additional bond from the carbon to the oxygen. So this is a 4-carbon alcohol. This is 1-butanol, right? 1, 2, 3, 4. Okay. This carbon has 2 H's attached. Okay, 1-butanol. All right. So to oxidize 1-butanol, let's keep the same carbons. 1, 2, 3, 4. What was a CO single bond will now become a CO double bond. And now that O can't have an H attached to it, because O just makes 2 bonds for it to be neutral. Okay? Can draw this carbon here now having just 1 H to it. Okay? So to oxidize this, we added what else did we do? A bond from hydrogen to what? Carbon? Yeah, we removed one. Yeah. So, and then bringing it back will reduce it. Okay? The reduction involved removing the CO bond and adding a CH bond. Okay? In this case, this one right here, this carbon, how many H's are on this carbon right here that I drew? Yeah, it's just 1 H. You can draw it like that. Something like that. So, what would we do here? What would I do to oxidize this alcohol? This is 2-butanol, right? What would I draw here attached to carbon number 2? Double bond. And that's it, right? We had to remove an H from the O. That doesn't count for oxidation reduction, but we removed an H from the C. We added a bond to we added an O bond there. Okay? So it can be oxidized to make that compound. We're going to come back to these because in a second we're going to be able to name these. These are different types of compounds. Okay? So we'll come back to those.